Alright guys, so yesterday we got logged into R on our Chromebooks, and today I'm going to show you how to do your qualitative data analysis using R. So with RStudio opened up, I'm going to go into my Google Drive, and you'll notice here I've created a R account, or an R folder, and I'm going to do the qualitative. So I'm going to open up my past data set, which was whether or not students are passing a majority of their data sets. Now, the way we had it formatted in the survey was they gave us our gender, and then they told us yes or no whether or not they were passing a majority of their classes. What you'll notice here is I have two additional columns. I'm going to go through how to make those two columns today. So what we need to be able to do is we need to be able to tally up how many males have passed and how many females are passing. So we're going to make a male and female column, and I went ahead and put gender in alphabetical order. So if you don't have it in alphabetical order, that's what you would need to do first. But here's all of my females. So we're going to copy all of the females' responses to whether or not they're passing a majority of their classes. So we're going to come in here, we're going to highlight all the females' responses. So we're going to go down and find our last female, and we're going to copy that into a list to where now I have an entire column of data of just my female students. And I'm going to repeat this process for my male students. So I'm coming down here to my first male student, and I'm going to copy all of the data of the male students into its new column. Now at this point, once we've done this, we could delete these first two columns here, but I'm going to just leave them up there because it's not going to hurt anything. So at this point, if we go into R, we're going to import a data set, and we want it to read R. It should bring us to this page, and it says that it wants us to tell it a file or a URL to use. And since we're doing it through our Google Docs, Google Sheets, we're going to need a URL. So to do that, we're going to go back to our Google Sheet. We're going to go to File. We're going to publish this to a website. So we're going to click Publish to the Web. And you do not want to link the entire document. You just want to do Sheet 1, which is just the first page of the document. And same as with saving it as a file, we don't want it to save as a web page. We want it to save it as a CSV, comma delimited file. And it says it's published, and when it publishes it, it'll give you this URL. So we're going to copy and then come into RStudio and paste that into our file. And then we're going to hit Update, and it's going to say it's retrieving, and it's going to give you a preview to say, hey, is this what your data set's supposed to look like? And if it is, you're going to come down here and click on Import. And when you do that, it's going to tell you, okay, it's brought it in, and it's reading this Google Doc URL, and this is the name of your data set right now. Now, that's not a very convenient name. So I'm going to come down here and type in data, and then just copy and paste that name that it gave it previously. And then now if I type in data, it actually just shows me my data set, but it doesn't, I don't have to use this extensive weird title. Now if I come over here, guys, to this environment tab, you'll see it has history. If I go to history, the history shows me any data command or any commands that I've previously written. So now down here I'm going to go through and do the attach data command. And now my data set is in R just like it was on the desktop, but I didn't have to go through that whole get the working directory or setting the working directory. That's how we now have the information in here. So now if I type in table male, it'll tell me how many males said no and how many males said yes. And then if I did table female, it will tell me that 6 females said no, they're not passing a majority of their class, and 85 males said they are passing a majority of their class. So now with that said, then what we can come in here and do is we can now do a bar plot of male, and it's telling me there's an error. So bar plot, oh, I know, we need to make a bar plot for the table of male. And it gives us this bar plot over here on the right side. Now from here we could right mouse click, or we could, from plots we can hit export, and we can save it as an image, or we can copy it to the clipboard. Either one of these would be a way for us to get it into a Google Doc. Now, if we can see, guys, this isn't that very colorful. So if we come in here, we can now type in Barplot table male, and we can add colors. And I don't know, since boys are typically thought of as blue, and girls are typically thought of as pink, as stereotypically incorrect as that may be, but that's how we'll go with it. Now if we hit enter, we can see that it adds color, and it adds color in the order in which we have here. Now this is the bar plot for male, so me adding no or yes as being blue and pink doesn't make much sense, because the bars are not males and females. The bars are yeses and nos. So yeses means that the students are passing the majority of their classes, which I would consider that to be awesome. So we'll put red and green in. So red is no, because that's not good, and green is yes, because that's great. And then we can come in here and we can add a title. So main equals, and we can do number of male students passing, or number of male students passing majority of classes. Or let's get rid of number of and just do male students passing majority of classes. And then if we run that, we can now have that, and we can export this and copy it into a Google Sheet. So let's just go ahead and maybe do that real quick. So let me open up Google. And let's just go to Google Sheets. Not Google Sheets, Google Docs. Sorry, guys. Go to Google Docs. Create a blank doc. And then if we go back to R now, we should be able to export, save as image, or copy to clipboard. And then now from here we can just do copy image. And then go over to our Google Doc and paste. And then now it's dropped into our Google Doc. And that's the same process you would do for all of these. You would do export, copy to clipboard, right mouse click, copy image. It does not give you the option to copy from here. But if you do the export, copy to clipboard, you can then copy from the clipboard. So just keep that in mind. So that's our bar plot. Now if I want to go in here and instead of doing a bar plot, I change the command bar plot to pie. It'll do the exact same thing, but it'll give us a pie chart. So then we can do the same thing. Export, copy to clipboard, copy image, go to our doc, and then drop it in. And you'll notice that it automatically color codes it to match. So that's good. All right, so that finishes up how to create a bar chart or a pie chart. So some of the other things you're going to need to be able to do is to run a proportion test. So the proportion test command is proportion.test, and you always want successes over total. And that's going to be the command. Now if I hit enter, it's going to tell me there's an error because it's not found. So I'm going to go ahead, and right now what I'm going to run is I'm going to use a hashtag, because hashtag male proportion test. So I'm going to do a proportion test, and if I look up here, I can see that I had 37 males that were successful. So I'm going to type in 37, comma, out of a total of 5 plus 37. Now, if you don't want to actually do that, you can just type in 5 plus 37, and it will run a one sample proportion test. Now, the whole point of that is it gives you a 95% confidence interval. So we can then copy this. We can go over to our untitled document, and we can do male 95% confidence interval. And so now we have our confidence interval for our paper. And so we can then do the, and then also, guys, it gives you the sample estimate. So if I go over here and drop that in, then from here, guys, we can say from this sample of 42 males, we see that 88.1% are passing a majority of their classes. Also, based on this sample, we are 95% confident that the true proportion of males at West Union High School who are passing a majority of their classes is between 73.6 and 95.5%. We got that information from up here. So that's our reporting of our confidence interval and our sample proportion. Now, one thing is here, we can do with a standard deviation of, and we need to calculate that standard deviation. So here's what we're going to do. We're going to come over to R, and remember guys, standard deviation is equal to the square root of P hat times Q hat divided by N. So what we're going to do is, look, we have P up here being 0.8809524. I got that from right here. So I'm going to name that P, and then I'm going to do standard deviation equals square root P times parentheses 1 minus P divided by, and there were a total of 42 males. And if I now type in standard deviation, it gives me the standard deviation. So we can see that the standard deviation, we'll copy that over to our untitled document. So we say from the sample of 42 males, 88.1% are passing the majority of their classes with a standard deviation of 5%. And that gives you everything you need to calculate. Now, you would repeat this process for the females. You would do all this that you did with the pie chart, with the bar chart, with the sample proportion, with the sample standard deviation, with the confidence interval. You do all that same exact process with the females. And then that would give us the information that we would need for our analysis of the females. So then we would talk about the assumptions, which is they need to be random, which you should have done that when we made our sample. And so we would say for this was a convenience sampling via school-wide survey. So that's how we made it random. Independence. The only independence issue may be if two friends were filling out the survey at the same time and the one not passing all of their classes, or majority, was embarrassed to admit to their friend, or maybe the surveyor or the respondent did not want to admit they were failing failing most of their courses. This may be an independence/bias issue. So binomial. Then the next one is they have to both be binomial distribution. The students only had the option to say they were or were not passing a majority of their classes, thus success fail. And then the success fail criteria. 146 people were surveyed. After cleaning the data, we had, well, let's go back to our R. We had 42 male, 37 yes, 5 no, and we had, let's go back up here to female. If we go back up here to female, we had 85 plus 6, 91 female. So we had 91 female, 85 yes, 6 no. So in both cases, we failed to have 10 no responses. And so that's going to be an issue with our results, but there's nothing we can do about it at that point in time unless we go collect more data. But in any case, we would acknowledge the fact that this may be an issue. So we had 10 no responses. We had failed to have 10 no responses. This may cause an issue with the results of the study. However, the study will be continued. All right, so then at this point now we're ready to do the two proportion t-test. All right, so then in your RStudio, guys, the way this works is we're still going to use the proportion test command, but you're going to come in here, you're going to do x equals c, and then you're going to do successes for the first group, successes for the second group. And then you're going to do n equals c, and you're going to do the total for the first group and the total for the second group. Now, obviously, it's going to tell me that this is an error, but from here, what we're going to do is we're going to do x equals c. In the males, there were a total of 37 successes, meaning 37 students. So this is 32 successes, or 37 successes in the males, which means 37 students are passing the majority of their classes. If we come up here, there was 85 females who are passing the majority of their classes. So there's 85 successes for the females. And then N is going to be listing out our totals. Now, since we put our males first over here in the successes box, we have to put our successes for our total for our males first. So going back up here, our total males was 5 plus 37, which is 42. And our total female was 85 plus 6, which is 91. And then we run that, it gives you all this information. So I'm going to just copy and paste all this. So copy. And you'll notice, guys, it gives us a lot of things. It tells us here's how it's reading. It's giving us a chi-square degree of freedom. It gives us a p-value. And it gives us a confidence interval. And notice here, guys, it gives us the proportion for group 1 and the proportion for group 2. That number there, 0.8809524, should look familiar. It's up here. So it calculates the sample proportion for each group, but it does not calculate the 95% confidence interval for each group. It only calculates the 95% confidence interval for the differences of the two groups. So from here, we can say, based on these two samples, or based on this sample of 42 males and 91 females, there is not statistically significant evidence of a difference in the proportion of females passing a majority of their classes compared to the proportion of males. And then at that point, you would just literally drop this line of information in. With chi-squared equal 0.48314, degree of freedom equal 1, p-value equal 0.487. The p-value is the important part, but we go ahead and just include the rest. And then we can also say, based on this sample of 42 males and 91 females, we are 95% confident that the difference and the proportion of males who are passing a majority of their classes compared to females is between and then we can drag this information in. And typically it would be negative 18.1% and 7.5%. So again, just convert that to percents, 7.5%. Now, going back up to this paragraph, guys, we know that there was not statistically significant evidence due to the fact that the p-value was greater than 0.05. Right here, we can then say this supports the results of our hypothesis test as 0% is within the interval, negative 18.1% to 7.5%. So that's pretty much our entire analysis. And then now we just put it in a paper format and we organize it and clean it up as the one I handed you out in class, handed out to you in class. So if my null hypothesis was, for me personally, I would think that the proportion of females who are passing a majority of the classes would be higher than males, because from what I've noticed in the past, females typically care more about their grades. This would show that my hypothesis was incorrect, that there really is no significant difference based on the data that I have at hand. So anyways, that's everything for this, guys. I know that's kind of a long video, but that gives you everything you need for this section of the final project. If you have any questions, guys, feel free to stop in and ask me for help. But this video, as long as you re-watch it over and over as you need, this has everything you should.